Hello everyone, I am Aniket Narendra Kungadkar, BTech third year electronics engineering student at Inlet Aurangabad. I am intern at Emertxe Information Technologies, Bangalore, in the domain of embedded systems and IoT. My internship was of 1 month under the guidance of Miss Jayalakshmi N. Dhanial and Miss Guhapriya S. Ma'am. So during this 1 month internship, I gained practical experience in embedded systems, IoT development, and real-time system implementation. Talking about internship overview, the internship was structured and spanned into 4 weeks. The first week was focused on strengthening programming skills in C and C++, while weeks 2 to 4 were dedicated to Arduino hardware, like introduction to IoT, embedded systems, and Arduino, then sensor interfacing, IoT concepts, and finally the development of a home automation IoT project. So each week helped me to build a step-by-step understanding from basic coding to full IoT system integration. Talking about week one, programming in C and C++. So in first week, I practiced programming in C and C++ fundamentals, or the topics which I worked like mainly arrays, function, pointers, variables, file handling. So I developed logic building skills for embedded C programming, which were properly required for embedded C. So which were efficiency and timing are key for microcontroller based application. In week two, we started with the basics of embedded system, so understanding how hardware and software work together. Here I learned about the Arduino Uno board, so it's microcontroller, input output pins and communication ports. I also done the simple programs like LED blinking, which was implemented to understand how instructions translate into hardware actions, and also explored the concept of real-time control and interfacing. Week 3, IoT fundamentals and sensor interfacing. In the third week, I moved to practical sensor interfacing IoT concepts. I connected devices such as 16 cross 2 LCD, LDR sensor, and temperature sensor. The mostly function which I have used like analog read and analog write functions, and understood IoT communication using the Blynk IoT platform. So this Blynk IoT platform also allows devices to connect and exchange the data with the smartphone app. So this week build the foundation for my final project. In the image also you can easily see how actuators, microcontroller sensors are mostly used in the environment like home or in any applications where the IoTs are used, the interfaces and the communication protocols. The final week, the week 4, was of the smart home automation project. The final week was completely focused on implementing my IoT project, which was smart home automation. So the project was designed and simulated using Pixim Lab with Arduino and the Blynk mobile IoT app. So the goal was to automate and remotely controlled household functions such as lighting, water tank level, temperature regulation, and Ethernet field also. The system was integrated with various sensors, actuators, and IoT connectivity. In the image also you can see how the home automation, all the applications which are used in the home are connected with the Pixim Lab, and the Pixim Lab is connected with the Blynk IoT mobile app. So this is how the project was done. In upcoming slides also and the demo video, I will be showing the proper working of my model. In here also we have developed the modules, different modules for garden lights, serial water tank, and the temperature control, and it integrated in a single file. So the modules included garden light automation using LDR. Then the second was serial remote and control. Third was temperature regulation system. So each module was linked to the Blynk IoT app, where I created buttons and controls to operate the system from mobile devices. In module 1, the garden light automation, I used the LDR sensor to detect the intensity of the light. When the light level dropped below threshold, for example during the evening or night, the garden lights turned on automatically. And when the sunlight increased, means when the LDR sensor is given high, so the light turned off. So this demonstrated that how ambient light sensing can automate outdoor lighting efficiently. In the image Arduino Uno is connected with the LDR sensor and lights. I will be showing these connections in the demo video. Yeah, in module 2, serial remote tank control, which was where the inlet and outlet valves could be controlled through the Blynk IoT app. So when the inlet valve was turned on from the app, the tank started filling until it reaches 3000 liters, after which it stopped automatically. And similarly, when the outlet valve was turned on, the tank level decreased until it reaches 2000 liters, and then it stopped. So this demonstrated and ensured that automated and remote water level management, the demonstrating IoT-based smart resources control. In the image also, you can easily see how Arduino Uno is connected with the water tank. So these are the pin connection, inlet valve control and the outlet valve control. And in Blynk IoT app, the buttons were created for the inlet valve control and outlet valve control, which was connected to the Arduino Uno. In module 3, temperature control system. So it used temperature sensor connected to the Arduino. When the heater button turned in the Blynk app was turned on, the temperature started increasing, and once it reaches 35 degrees Celsius, then the heater turned off automatically. So when the cooler button was turned activated, the temperature dropped and the fan turned on. And the temperature will drop till 27.5 degrees Celsius because it was ambient temperature. So this was about temperature sensor, which shows that how IoT can monitor and regulate environmental conditions in real time. In the image also, you can easily see how temperature system is connected with the Arduino Uno with heater control and cooler control pins. And Blynk IoT app, the buttons were created for the temperature, heater control and cooler control. Hardware and software setup. So the project was implemented on PiximLab Arduino simulation board. Mainly the components which were used like LCD display, 16 cross to LCD displays for output, LDR sensor for light detection, temperature sensor for climate monitoring, LEDs and relays for indicator control, Ethernet shield for IoT connectivity, and finally the main thing was Blynk IoT mobile app, which was acting as a user interface for all remote applications. So this was combination created full end-to-end IoT environment. In the image, you can see this were the Blynk mobile IoT app, where the in tab one you can see inlet control and outlet control. This was for serial time, and in tab two, in image two, you can see the heater and cooler. So these were the buttons created in the Blynk mobile IoT app. In third image, you can see the Pixim Lab spare parts. The temperature is showing and the volume is also showing. The heater flow is on, inlet flow is on. So this is just a screenshot. In demo video, I will be showing how it will be working. So yes, let's move on towards the demo video. So this is a Blynk IoT app. Let me open it. I'm connecting the serial tank. Let me load the hex file. This is my hex file which I have generated. Let me open it. Yeah, so home automation. Yes, here you can see uh, the inlet valve is on and the tank is started filling. Right. So tank will be start filling till 3000 liters, and here also you can see the number has been written. So yes, you can here also you can see till 3000 liters the tank will be filling, and here also you can see the inlet flow is on. Now if I off this inlet flow, here it is written inlet flow is off, and here also the switch uh, disclose, right? Okay. Now if I on this outlet valve, so you can see here the water tank will become empty, and water tank will become empty till 2000 liters only. It won't go beyond that because in the code we have already written that it will go till 2000 liters. Yes. So it has stopped here, and here also you can see. So outlet flow is off and inlet flow is now inlet flow is off. So this is off, disconnected, and inlet flow is on. Inlet flow is on. So this will be filling till 3000 liters. So this was serial tank. Now talking about the garden lights. So these are the garden lights. If I'm decreasing, means if no sunlight is there, light will be off. That is here which is indicating, right? And if it is night or evening time, then light will be on. So this is how the garden lights were made through the LDR sensor. Means LDR is working at sunlight, and here lights has been connected. So this is also working. Yes, and now I will be showing this heater and cooler temperature. So here if I on this heater button, you can see the temperature rises, right? Here also you can see the temperature goes. Here also you can see. So it will go still 35 for 35, and heater automatically turns off, right? Here heater automatically turns off. Now if I on this cooler button, you can see the cooler is on. Here also cooler is on, and the temperature is also decreasing. So temperature will decrease till 27 point ambient temperature, till only ambient temperature it will decrease, because ambient temperature is 27.5, right? If I off this cooler, the cooler is off. Yes, so this was my total project which I have shown. So let me close this. Yeah, the results and observation. So we can easily see all the modules function properly. Yes, so we have already seen that uh, LDR sensors, temperature sensor, and Ethernet shield was working properly, right? Also, I will show you the Arduino board. So this was the Arduino board which were working. Arduino Uno board, and so yes, real-time monitoring were controlled via Blynk mobile IoT app, and also I have demonstrated full integration of embedded and IoT systems. So the project demonstrated how multiple embedded systems, sensors, actuators, and communication modules can work together to create a smart connected home. Talking about key learnings, so through the internship at Emertxe, I gained hands-on experience in embedded system programming. So embedded programming and sensor interfacing. I got practical understanding of sensor interfacing and control logic, the project design, debugging. I also got confidence in design and simulate complex embedded projects. So enhanced problem solving and analytical thinking. So this experience strengthened my technical and analytical thinking in embedded and IoT applications. Lastly, I would like to conclude that this embedded and IoT internship at Emertxe had provided a perfect blend of programming, hardware interfacing, and IoT system design. As it gained expertise in integrating sensors with IoT platforms, it was grateful to Emertxe mentors for their guidance and support. Really, because they have given full guidance and full support, and because of them, I was really able to complete this project. So I sincerely thanks Emertxe Information Technologies and my mentors for their guidance and support throughout the internship. So thank you, Emertxe, for a great learning experience.